Hey class, this is our final video. It is on solving quadratic equations. You're solving by factoring, and this is where a does not equal 1. So we're going to be factoring this, and then from that, solving. Okay, so with we have ax squared plus bx plus c, and this is equal to 0. So this tells me it's an equation, and that I have to solve. Alright, so with this, our example will be, so it's the same steps as the previous video on just factoring where a does not equal 1. Okay, so we're going to have, our example here is going to be 3x squared plus 13x plus 12 equal to 0. Okay, so remember from x factor, b is on top, a times c is on the bottom. Okay, so our b term here is a 13, and a times c, which is 3 times 12, which is 36. So I'm thinking to myself, what numbers do I add to get 13, and what numbers do I multiply to get 36? It turns out that those numbers will be, they will be 9 and 4. Okay, if I add them, it's 13. If I multiply them, it's 36. So it works out. So with this, I split the b term, which is my second step. So I'm going to write 3x squared, right? That was our first term. We're going to split the b term, so let's come back to that. We're going to write the last term, which is our c, which is a positive 12. This is equal to 0. So I use my x factor. I wrote these numbers here. I have a positive 9, so I split the b term. And this term over here, I can rewrite 13x as a positive 9x plus 4x. Okay, and that's true, right? 9x plus 4x is 13x. So with this, I factor by grouping. I'm going to group the first two terms, and group the last two terms. Well, let's see what we can factor out that's in common in these two, and then in these two. Well, over here, we have a 3x squared and a 9x, so I can factor out a 3x, looks like. Right, 3 can go into 3, and it can also go into 9. And I can take out one of these x's, right, x to the first power, because we have 2 over here, and 1 over here. How many do they have in common? It's just x to the first power. Okay, let's draw our parentheses. We're going to fill that in later. Over here, 4x and plus 12, I take out a positive 4, right? 4 is the biggest number that I can go into 4 and 12 at the same time. We can't take out any x's because this last term doesn't have any x's. Alright, and we're going to write that, and that'll be equal to 0. Okay, now is the question on what do I put in the insides to make these true? 3x times what gives me 3x squared? Well, that's just a x, right? 3x times x is 3x squared. And 3x times what gives me 9x? Well, it turns out it's just a positive 3. Okay. So we put that in the first term. I'm gonna cheat again. I'm gonna put that in the last two. Let's see if this works out. They should be the exact same thing when we factor by grouping. So 4 times x is 4x, true. 4 times 3 is 12, so that's also true. With this, we factor by grouping, meaning I group the numbers on the outside, or terms on the outside, and terms on the inside. So what were the numbers on the outside? It was a 3x and 4. So I'm going to write that in one of these parentheses. 3x plus 4. Okay. What was on the inside of the parentheses? They had a common set of parentheses. It was just x plus 3. And that's equal to 0. So when we factor by grouping, this is what we had. We just had a product of binomials, and that was it, right? That would be our answer normally. But in this case, we're solving, okay? Which means I do have to use the zero product property, meaning I have something times something equal to 0, set them both equal to 0. And this is also known as, if you remember from the solving a equal to 1, a student's worst nightmare. So I'm going to try to fit this in with the little room I have, but we're going to have 3x plus 4 equal to 0, and x plus 3 equal to 0. Well, you're just solving for x in this case, so I'm really asking myself the question as, what do I put into x that if I multiply by 3, add to 4 gives me 0? And what do I put in for x that when I put that into there, add it to 3, it equals 0? So you can kind of maybe intuitively think that way, or we can use inverses here to get rid of it. So over here, if I want to solve for x, let's get rid of kind of the furthest thing from it, which is this positive 4. So I'm going to subtract 4 to both sides. So in this case, if I do that, we're going to have 3x equal to negative 4. And finally, I'd have to get rid of our coefficient of 3, so I'd have to divide by 3. Okay. And if I did that, x is equal to negative 4/3. I'm perfectly okay with you writing it as an improper fraction, and that is one of our solutions. It's a fraction, it's messy, but it's okay. So we have x equal to negative 4/3. In this case, we would subtract 3 to solve for x. And a lot easier here, we're just going to get x equal to 0 minus 3 is a negative 3. And that's it. And if I were to put these solutions into our equation, it would satisfy. And that is how you do solving quadratics where a does not equal 1. Alright, bye.